Okay, NBs, girls, boys, everyone else, what is up? What is up? I am joined today by coffee and a bowl of oatmeal for some reason. It's saying we're unstable. Are we good? Doesn't look like we're dropping frames, so I think we're good. Worst case scenario, there will be a VOD. Average stream bitrate is too high. Shit. Can I change that on the fly? Stream. Uh, did I just leak the key? No, okay, perfect. I think we're fine, right? Like, uh, 25,000. Is that okay? Is that better? What's the stream bitrate at? 5,000 kilobits per second. I think we'll be okay. I mean, it looks like, yeah, the stream looks fine. Okay, cool. Cool. So, what are we doing today? So today we are going to be writing an immediate mode UI library in Rust. Um, and what is an immediate mode UI library? So you might know, let me create a new browser window. So you might know like Dear image UI, and I'll put this in the description of the VOD. But basically what it does is you give it sort of a very basic API for drawing things, usually SDL. I guess you could use something like Raylib now or just like OpenGL by itself. But anyways, you give it a very minimal UI library, graphics library, and basically it just draws pixels on the screen, and it abstracts over that to let you create UIs. So this basically makes it super easy to port your applications to different operating systems. It's often used to make interfaces inside games, like consoles, menus, whatnot. I've seen it used a lot in audio software like VSTs, like synthesizers and audio effects and stuff. Maybe we'll do some of that in the future. But yeah, basically we're going to be drawing everything from scratch. We're not relying on, Win API or Cocoa or anything to use the built-in operating system UI stuff. So yeah, let me just double check that we're not dropping frames. It's still telling me I'm unstable. Oh, we're excellent now. Okay, guess we fixed it. That's a win. Okay, so we need a name. So there's electron, right? So I was thinking like parts of an atom, neutron, proton. Does proton exist? Is there like a proton GUI library? Oops. Oh shit, wait, what is this? Proton up. Oh, proton, like the steam thing, exists. So I don't think we should use that. Nucleus contains protons and neutrons. That's kind of goofy. Um, yeah, what should we call it? I'm kind of. We could just go on a. Oh, you know what we could do? We could translate electron to like a different language. Diansu, that wouldn't work. Oh shit, I don't know why it looks like this. Bengali. Uh, um, electron, that's pretty much the same. Electron, the Welsh electron. So we're not getting very far in terms of naming it. I think naming it is like half the struggle, right? So I don't even know, to be honest. We could do like ion. Let's check crates IO. Shit, well, is this like abandoned? How many downloads? I don't know, 72,000, so it's pretty. Let's go with, is ion UI? All right, we're doing, we want to do ion UI. Well, I'm trying to like think back to like AP calculus and like all this shit, or not calculus, like chemistry, and remember like what we did. Is there a neutron? Of course there's neutron. There's probably proton as well, yeah. Quark? Damn, I mean everything is taken up. Is there like quark related words? Hadron. Oh my god. Fermion. Okay, is anyone watching? I don't think so. Oh, let's get the Twitch chat up. Also. Yogurt, gold leaf, Rom, Kvarg, CERN, Frankie, Squark, Quark cheese, Subatom, Moat, Helion. That sounds cool. Wisp. Laser Chet, Swirl, Murex, Erg. I don't know what any of these words mean, to be 100% honest. Dogpile. Valence electron. Ionic already exists. I know that. Axion. Of course it exists. Reserve name. That's helpful. Okay. Charm is kind of cute because you could call like the widgets like charms. I know charm is going to be taken, and it's of course a WIP. Maybe we'll do charm UI or charms. Let's do charm UI. So let's say cargo new lib charm UI. Cargo.toml and okay, so I guess it's gonna be charm underscore UI in the in when you actually use it in a Rust project, which I think is a bit unfortunate having to add that, but I think it's a cute name. So I think the idea in the future is that you'll be able to pick and choose a backend. So what we could do is basically make the graphics library a feature, and we could also give the user the option to implement their own graphics libraries. So maybe what we'll do is we'll create a generic trait for graphics libraries, but for now, let's just add SDL2. And do we need any of these features? Let's add TTF. Oops, features TTF. Okay. Cool. So here's our library. I'm just gonna delete everything. And how should we do this? Let's create a pub struct. And how do we want to do this? Actually, I think a good way to go about this would be to create a examples folder. And let me double check cargo run dash example. If I run it like that, it'll work. Okay, perfect. So we can have, let's call this basic.rs, and let's make a basic example. So let's think about how we want our API to look. So I'm thinking we have something kind of like a React setup where we have this sort of idea of components. So let's say we have app : and let's say that window equals window : with size, say 1280. No, let's just say 800 by 600 for now. And we could even have it like a builder pattern where it could be like this, window new with size or something. Right, okay, we can ignore that for now. We ignore all like that. Wait, how do we allow all, right? Is it like that? No. Allow okay, whatever. We will just ignore it for now. So let's say we have an app new, and we have a window. LSP stop. Oh, there we go. There we go. And disable. There we go. So we can have a window with size and with background. And I'm thinking we have like a create into color, um, or something, and then we can implement import into color for U8, 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 like an RGB tuple. And so we can say with background 0, 0, 0, which would be black. So we can have that. And we can say app.add window. Maybe there's a better name for that. And you can say app.run. And essentially this will start the main loop, and our program will, like, this shouldn't exit until the app quits. Basically, it'll render everything and run the event loops and basically run our app. And that is to say that up until this point, up until line 17 here, we're not rendering anything. We're just building up, in a sense, sort of this virtual DOM, the structure, sort of like a blueprint defining how we want our app to look. And then when we call run, we're actually rendering the app and, you know, calculating everything that needs to be calculated and you know, all that stuff. So let's talk about how components will look, which is kind of tough. Okay. So, and let's keep this at the bottom, and let's say window new, window, don't want to say with children. Dot root. This will be mutable. We'll say window dot set component or set root component or something. And how about we can create main. We can create, actually, let's say box new, box with children, with child. How do we want to, like, I want this to sort of be like Flutter, if you've ever used Flutter, or maybe Swift UI, but obviously we can't really get that clean of an API unless we do something like use a macro. Like, we could have something like if you've ever used there's like a HTML macro, and then you can kind of just like start writing HTML in Rust, which is kind of cool, but it's also a huge nightmare to implement something like that, and I really don't want to, especially because it'll make error reporting like act really strange too. Let's say with child or add child. This formatting is really weird. I don't know why it's doing this. So add child, text new, hello world or something. And then we can say with size. No, let's not say with size. Let's make it. Yeah, let's say with size. $400 by 300, just for now. We can add things like, we're gonna add like flexbox layouts and stuff like that soon. And let's say with background. Actually, let's not do fill like width, just to make it easier, because if you're actually building a whole application in this library, you're going to be typing these things like a lot. And I'm actually going to say, no, I'm actually going to keep it to background. I think that's more user-friendly, because if you render something in the box, like a text, you're going to expect background to stay in the background, and fill would be like filling the whole rectangle, essentially. So let's do background. And let's make this red for now. So I think this seems like a decent, oops. I don't know why my formatting is like this. I think this is a decent start to our API, and this text can be like .fill 255, 255, 255 white, right? Okay. And we probably won't start with text, because that means we have to handle like text stuff, which is a ginormous pain in the ass. So let's keep it simple. And actually, I think something we're gonna want is reactivity. So say we have a a struct of store, and say we want, actually this is a good way to test this out. Let's add a child here, and we're gonna make a button new, and it's gonna be +1, and that's all. It's just gonna be like that. And we'll have a store, and we'll have something like count, which will be a use size. Yeah. And we don't need to do all that. So we can create a store. Count with 0. And we can do something like, say, app with store, and that could be I think we'll just consume the store here for now, because we're probably gonna have to do some interesting things where we like throw around the ownership. But here's what we can do. We can say button new dot on click, or on click store mute store store.count plus equals 1. And I think this might not be possible, but I think we might be able to have it where we can make any parameter take a closure instead of just a instead of just a constant value. And then we could do something like clicked x times, right? Store.count, right? So it could theoretically be this easy to make a simple application that tracks that shows a text in a button, and when you click the button, it shows you how many times you've clicked it. So let's try to make this work. So let's import everything that we're gonna want. So we want charm UI, charms, text, button, and we're calling the widgets charm. That's our quirk. That's our little like JavaScript moment, or like Rust moment, I guess, because like crates, charms. But yeah, that should be everything we need. Cool, so let's go source lib, and let's pull up our example so that we can kind of reference it. And it is gonna complain. Oh, we might not be able to use box because it's Rust, and we really don't want to overwrite box. We should really find a better name. We could have an HTML moment and call it div. I really don't like the name div. I like box. I really want to use box, but we could say view, maybe. Or we could call it like H stack for like a horizontal stack, or V stack for a vertical stack. Let's do V stack for now. And if we don't like it, we can change it later. Cool. Okay. Now, obstruct app, and app will actually be generic over store. And for now, we'll just store a store. And can we do the default here? Oh, we can. That's fantastic. Okay. Clone. No, let's not clone. Let's just do debug. And let's import store app store. And we'll say pub function new self store unit expected store find unit. Oh, we need to do this separately. This needs to be like that. And then we can do import store app store pub function with store self store. Cool. So we have an app. Let's create window. So window can have a size, which will be a tuple of view sizes, which will change eventually, probably. Oops, we'll derive debug. Windows can be clonable. I don't see why not, because you might want to make two of the same window and then change them. Just gonna have some oatmeal. then we could have roots and I'm thinking we make window generic over component. I'm thinking we include types in the components that wrap them, unless we have a component like vstack where we're going to need type erasure, because vstack can have multiple children of different types, so we're going to have to erase the types, right? We're going to have to do a boxed in component or something like that. So there we go. And here's the issue. We're gonna need, this is gonna have to be option, I think, because we have a point at which window can be nothing. And I think component by default will also be unit, and we'll make it so that when we implement our component trait, if it's unit, it'll just render nothing. I think that's fair. Yeah, so impl impl component window component call function new. We'll say size. Ooh, we need it. This also needs to be. I don't know if we want like a default size. Let's just call it option for now. Yeah, okay. If we want to require a size, we might just put it in the new, in the constructor. I mean, we might just say like with size. Let's do that actually, yeah. And let's also take a tuple instead of 2 arguments, so that you can store a size as a variable somewhere and reuse it if you want. So let's say size, and let's say root is none. And how are we looking? I get really anxious that it like disconnected or something, but I think we're good. Yeah, we look good. Okay, cool. So let's change our example here to be with size 800 by 600, and we'll nuke that. Okay. Background. Okay. Cool. And we'll have a background as well, which can be an option of color, and we'll define color in a sec. But we'll say background for now. And when you say pub function background, we'll return that and we'll say self.background equals background, and this is actually going to import into color. Okay, let's define color. So pub struct color R G B. That actually, yeah, that's going to be, these aren't going to be U sizes actually, these are going to be U8s. And we will do derive debug clone copy partial eq partial ord. We're derive maxing right now. And we'll import into color for u size, not u sizes. I keep using u sizes, but it's u8. And we will do function into. And are we gonna get yelled at for not doing a from? Are we supposed to do a from? I think into is good. Right, okay. If I cd into charm UI and I do cargo clippy, are we okay? Implementation of from is preferred, so I think that's okay. So we'll do from u8 for color. Function from value u8. And actually what we can do here is we can say RGB, and we can do self, and we'll use self here, not color. RGBA is going to be 1.0. Oh, sorry, not 1.0, 255. And let's do that for a 4 number tuple as well. So we can have alpha right, okay. And we can even do like a hex code or something, right? So like we could have it be a U32. We could have input U32. We could say let R equals, R is gonna be the, so if you don't know how this works actually, so you have a color like this, FF, which is white actually, right? Actually, this is a terrible example. Let's do FF00FF, which is going to be red and blue mixed together. Or sorry, what am I thinking? Red and green. No, red and blue, because it's RGB. So our R is going to be FF, or 0xFF. Our G is going to be 0x00, and our B is going to be 0xFF. And so basically we can use bit shift to get these. So what we can do is we can say 0xFF 00FF bit shift 4, and that should equal 0xFF. So R is going to be input 4, G is going to be input 2, and 0. Oh, I'm sorry. It's not 4. This is a 4 bytes, so it's actually going to be 4 times 8, I believe. We just 4 times 8. No, it's actually 16. It's 4 times 4. I'm sorry. Or 2 times 8 would be better. So this is actually going to be 8. 1 times 8. And 0xF. And this is also going to be 0xFF. And what this and is doing is it's just taking the only the last 2, or only the last byte of, it's only taking the last byte. It's clearing out any high bits. And let's do this here. But I don't know what it's mad about. Oh, because these are U32, so we gotta as U8, right? And as U8, as U8, right? So yeah, cool. Actually, you know what? We're missing alpha. We actually have we actually represent it with the alpha at the end. So actually what we're gonna do is have an alpha here and shift each of these up like that. There we go. Now, just as a sanity check, right? Let's write a quick test. Mod tests, tests, pub function test color, color from impl or something. And we'll use super, and we'll say color from 0xff00ff to EE 22. And so we'll have different things for each color component thingy will assert c.r equals 0xff. Oh, right. Oh, there's assert equals. Let's use that actually. And G should be 0, 0, and B should be 2, 2, and alpha should be E, right? So, oops, charm, carpet T. Okay, well, our example doesn't compile, so here's what we're gonna do. Boom, it works. Amazing. Okay, and let me remove this. So we have color now, and I'll probably put that in a separate file later, the whole color implementation, just because it's like its own thing. But here we have background is impl into color, so that's really great. So we'll say self.background equals background.into, or we'll say fill, yeah, color. Just fill, because the type describes that it's a color. There we go, and then we'll return self. So we'll have kind of a builder pattern, and this needs an impl to make it. When you add impl here, it needs to be some also, my bad. When you add impl here, it basically creates a generic function like this, and it's basically functionally equivalent to this code. Sorry, into color. It's into color. It's functionally equivalent, but the shorthand impl just makes it so much easier, especially in API design. Just because your user will read this in the docs and it'll just say, oh, fill has to be something that implements into color. That's easy. That's much easier than it being like fill is F, and then the user has to go, what is F? Well, F is some generic term that implements into color, right? So we use impl. It makes it nice. Cool. What next? Set root component. Set root component. Component is going to be a component. Cool. Easy enough. And okay. I'm getting ahead of myself. I apologize. Let's actually, oops. I think we want window to erase its type. And the reason why is because app is going to store a list of windows. And because of that, we need the type of the component to be erased. Otherwise, we'd have to make app generic over the type of the root component in the window as well. And we also wouldn't be able to store windows which have different component types. So here's what we'll do. I think we'll do option box div component, and we're gonna create a component trait in a minute, I promise. And so actually here, we're gonna go C, and we're gonna say where's C implements component, and sorry, this is gonna be C. And C has to be static also, which I don't know if anyone else had this misconception, but when I was first learning Rust and I was playing around with the static lifetime, I assumed that requiring it as a trait bound for some generic argument would mean that we need it to live for the entire lifetime of the application, basically like a static reference would, like a constant variable or something. But this actually, the static lifetime, it applies to owned things too. So since we're passing ownership of the component to the window, it implements static, but that doesn't necessarily mean that we can't drop it, right? So it's totally okay to use static here. It just means that we can basically take ownership of our generic component, which is what we want. So we're gonna box this. And let's go all the way down here, above color, and we're gonna create a pub trait component. And okay, let's require a function render. And this function is basically going to give our component everything it needs to draw itself in terms of pixels. And so this is going to contain, it's going to need information like, what is the size of my parent container? And actually, in the case of something like a flexbox layout, where we might have dynamic sizes, the parent might want to give the children something like height divided by 3 if there's 3 elements. And what I'm saying is we need to pass down a bounding box, and we also need to pass down sort of an interface that lets the component draw its things. So we might pass down like a render handle or something. And we're also going to pass the store. So we're going to have context, which is going to be a unit for now until we create the context. Actually, we'll create render context like that. And do we want this generic over store? We will deal with it later. And let's create a result. Let's just use an IO result for now. Cool. And we don't need pub. Let's create render CTX, and we will do bounds, and this will be a bounds. What bound will be is an X, a Y, a width, and a height. And we can derive all sorts of stuff here. Debug, clone, copy, partial eq, partial ord. It's always good practice to just define debug on everything. Now, this is going to need to be Can we do mutable self? Do we want to do that? Yes, we do. We don't want it to be mutable. I don't think we do. Okay. We have errors. Component is not clone. Oops. Do we want component to be clone? We are going to remove clone from window for now and deal with that later, I think. We can even do something there. Okay. What is it mad about me saying debug like this? Do we need to use debug like this? First non-auto trait. Only auto traits can be used as additional traits. I see. Okay. I think we need to define component. Component needs to be debugged necessarily. Now Windows can be a vec. Windows can be a vec. Okay, amazing, incredible. Okay. So how far are we? We have Windows, we have the app, we have a component trait. So let's try to make a window up here, because it's been how long now? It's been about 54 minutes. We're almost coming up on our first hour. And so I think it's time for something that isn't really incredibly boring to happen. I think we should get a window running. So let's actually uncomment all this code. And let's comment out the charms. And let's remove the comments here. And we're going to just comment out the root component part of this. Just try to get a window to show. Great. No method add window on type app store. Let's add window, I think. Cloud function add window. And I suppose we could return the reference in case they wanted to add multiple windows. So we'll say self.windows.push window. Perfect. I'm curious. I know why this happens. This is really annoying. And this is a thing that happens with the builder pattern where we don't get the own reference back. Can we dereference this? We can. Fantastic. Okay. Okay, and then we need a run method on app. And let's have that consume self and return an IO result, I think. And we'll go ahead and unwrap. And we'll say okay. Oops, we'll say okay. Sorry, standard IO. And I'm just using standard IO result right now because it's easy, but we'll probably swap that out for our own error type. Right, okay, so first of all, app needs to be mutable. And this is not allowed, so let's do that for now, and we'll come back and try to make that suck less later, because that's gonna be an especially big problem when we work on our API here. We might need to make these consuming. In fact, let's just make it consuming. I really didn't want to because it makes it so that when you do window.background, you would have to say window equals window.background, which is really strange, but it's going to make the builder pattern so much nicer. So there we go. And this doesn't need to be mutable anymore. Okay, so when we run our app, what should happen? So actually, we're gonna start getting into SDL. So let me pull up the SDL2 docs. Let's go to the documentation. And I know I said we're gonna work on ripping out the engine into its own like thing, but let's not do that for now. Let's just use SDL for now, and then we'll come back and we'll make it generic when we go into the render context stuff. So here's what we're gonna do. We're gonna go into run, and we have to do all this stuff. And can we just... Perfect. Yeah, for window in Windows. Self.windows. Let's SDL window equals video subsystem dot window. And we don't have titles yet. Let's add title. My first window. And let's add a title. We'll just do an option string for now. And I always do input into string whenever I'm taking in a string in an API, just because the user might want to pass in a string slice like we're doing here, which is a static string slice, or they might want to use something like format, which will generate an own string. And so we can make it painless by just using an into string in our API. So there we go. Yeah. Title dot window dot oh no window dot title dot unwrap, or what will our default title be? Just nothing. That, I think that's fine. Expected stir. Oh, this expects a reference, and then width would be window.size.0 and window.size.1. And it's going to be an incompatible type because it expects a U32, but we have a usize. Big fucking deal. Okay, crazy. There we go. Is this the result? No, you don't need to unwrap that. We do need to build it and then unwrap it. And I'm actually gonna do position centered on this. We can deal with position, adding position parameters and stuff later, but let's do that. And we will turn the window into a canvas, like that. And here's what we're gonna do. I don't think it's necessary to do all this stuff. So the issue here is that we have to create the window, and then we have to update it when we run. So what I think we need to do, is say let running windows or something, let windows equals a vec new. Vec new. And we're gonna push window and canvas. Oops, sorry. We're gonna push a tuple. And what this is gonna let us do, this needs to be mutable, is we'll have a list of canvases that were created from the windows. So, and we can even consume that. We can make that consuming because we consume the app. So then when we run our event loop, so we'll create an event pump. I don't think we actually need I, because they're kind of like making an animation here with that. I don't think we need that. Curious why there's a sleep here. Is it gonna? Yeah. Oh, this is for the animation to make it sleep. Okay, so we'll create a loop and we'll deal with events. Before event in event pump dot pull iter match event quit. Timestamp, we don't need that. Return or break running. Event key down. God, okay. There's this bug with auto pairs where it sometimes like won't make a new pair, which is kind of annoying. Key code. Oh, the dot has to be after. I always forget that because in JavaScript it's like the other way around. Escape. Oh, and we can just use this. Oops. And we can say, cool. And we'll change this. And then we just need to catch the rest and do nothing. Cool. And so what we'll do is we'll say for window canvas in and ref. Oops. Ref, I think, in Windows. Oops. In Windows. Can we do that? No. Like that, right? And then we can say canvas.set draw color window.background dot unwrap or color. Oh, and we're gonna need to they have their own color type, so we're gonna do like that. We're gonna say sample from color for STL color. We can do that, right? Okay, cool. Oh shit, my bad. Function from STL color RGBA. Oops, RGBA. We can do RGBA like that. Just do RGBA, and it's probably going to be a different integer type. Oh my gosh, it's not. Let's go. Okay. Cool. Now we can say unwrap or color from let's do black dot into and canvas dot clear, and that should be everything we need. And then we need canvas dot present after all this stuff happens, basically. And I don't know why there's a sleep. I don't think we need it, but we will see. And we need to present it actually, because there's multiple canvases. Okay, let's try it. I'm not expecting it to work, but yeah, there's an issue. String is not implemented. Okay, so these can't actually be converted into IO errors. So let's just unwrap them. Oh, I see. This API accepts an into, so we can just do that. Partially moved value. Why is it partially moved? Oh, it's because we're unwrapping it here. That's annoying. I think we can do something like that. There we go. Okay, I think this has to do with building STL. So let me try that. Oh shit. Okay. Oh, SDL to TTF. Okay, here's what I'm gonna do. I'm gonna disable the TTF features for now because I don't think I have SDL to TTF installed. So we'll come back around to that later. Would you look at that? We have a window, and let's see if we fill it with like blue or some random color, will it change? Isn't that incredible? We have a window. Yeah, there we go. And we can also change the size. So let's do like 1200 by 600. Look at that. Look at that. Only an hour and 10 minutes. Okay. Interestingly, the chat keeps closing. Yeah, okay, so we have a window. Library's done. Okay. One sec. Coffee, water. What are we gonna do? So, let's go ahead and create. Actually, first thing I'm gonna do is I'm gonna get in it this repo, and I'm going to git add dot, and I'm going to commit. Initial commit wave or something, or we can do ta-da, and we'll add an exclamation point. Amazing. Okay, we have our first commit, which is a working window, which is really fun and crazy and silly and goofy. So when we call our window for rendering, we're going to want to give it we're going to pass it the render context, and it's going to, we're basically going to pass control to the window, and we're going to say, like, we bootstrapped everything for you, now you render what you need to render, and the window is going to render its child components. And if those child components have their own children, they're going to render those, right? Make sense? So so we're going to do function render root, or render, just render. We'll just do render, and we'll say mute self. I don't know if we need mute. We'll just keep it self unless we need mute. Not component. Context. I suppose this could be treated as a component, but a window is not technically a component, and I don't want you to be able to like embed a window into another like component, because that just wouldn't work. So we're going to keep the render function in the window implementation instead of implementing the component trait. So context is going to be let's just do the SDL context, and we'll do a mutable SDL to render canvas. SDL to, where's the window? Render. Oh, is this the window canvas? Okay. Actually, here's what I'm gonna do. Type result, type farm result equals standard IO result. Look at that. There we go. Now we can go in and say, farm result. And we can use charm results. Oops. There we go. Remove these generics. Oh, I see. Type charm result T. Charm result. Okay. Okay, so here's what's gonna happen. We need to create a render context, and render context bounds. It's going to be a bounds, and the x is going to be 0, the y is going to be 0 because we're starting at the top left of the window. The width is going to be self.size.0. The height is going to be self.size.1. Okay. Actually, I think in our render context, I'm going to start adding. I'm going to start abstracting over the SDL rendering methods because otherwise the application is going to be really heavily tied to SDL, and I don't really want that. Yeah, okay. So Canvas is going to include, and the unfortunate thing here is that I think render context is going to need a lifetime. Because then we're going to need SDL2 render window canvas, something like that. Of course, it doesn't implement the bug. Okay, we'll deal with that later. And canvas is going to be canvas, right? Okay, cool. Int impl a render context a. And we're also going to need to change our component something like that. Don't actually think these need to be the same lifetime necessarily, but we'll get to that when we get to that. So here's what we're gonna do. We're gonna duplicate the render or fill method, and that's gonna be bounds and color. It's going to be a color. So we're going to do self.canvas.fillRect. And do we want the bounds to be relative to the render context? I don't think. Okay, here's what we're gonna do. Okay, where's the rectangle type? Rect, yeah. Let's say bounds.x plus self.bounds.x. Although this makes it kind of a pain in the ass to render things in absolute positioning. We'll just use bounds.x, bounds.y, and bounds.width, and bounds.height, and these are U sizes. We need them to be U32s. Like that. Expected I32, really? Okay. Bro, okay. Stop, please. Okay. And this is also going to return a results. And oh, we need to do self.canvas.set draw color color. And since our color implements into for the SDL color type, it's super easy for us. We don't have to put the into thing there explicitly. So that's a win. Cool. So then in window, you can say if let some component or some root equals self.root root.render context. There we go. Cool. There we go. So we can now define our first component, I think, which is going to be the VStack. And I'm kind of getting tired of working in this giant file. So let's actually do a bit of a refactor. So let's go source and let's touch app.rs, let's touch window.rs, color.rs. Is that all? Yeah, okay. And where should we put charm result? That'll stay in it. So here's what we're gonna do. We're gonna take this and move it here, and we're going to, we don't need this anymore, I don't think. We're gonna take everything that has to do with app, and we're gonna open app.rs and we're gonna just paste that right in there. And then in here, we're going to say mod app, use app, oops, app. And same thing with window. 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 Pub use window. Window. Where's render context gonna go? And where's bounds gonna go? Should we separate them or should we keep them together? I think. How does, so at STL, the STL library has a module called rect for this. Let's just, oh, it's called layout. I like layout. Let's do layout.rs. And we'll just plop the bounds in there. We can even import from usize for bounds, because like, why not, right? Let's include this in our layout. And actually, let's just keep this in its own module. Let's not clutter our namespace too much. Okay. And then let's touch component.rs. And also let's actually implement this. So cool. Okay, and component.rs. Pub mod components, pub, or not pub, pub use component. I don't want render context to be there. That's what we're gonna do. Perfect. Okay, so use super. Oh, we still have to do color really quick. So let's do that first. Color. There we go. Oops. And should not have any private fields. Oops, sorry. There we go. Neither should color either. This should also be very much public. There we go. Okay, so let's just go through the errors and use super window. All this stuff is private, and this actually should be private, but it should be public to our crate. Because we should be able to do stuff with these fields, but the user shouldn't, really. They should be using the methods we gave them. Color. Cool. Super color. Oops. Wow. Okay. Color component. Super component. Render context. I thought we fixed this. Why is it still saying this is private? What about this is private? Oh, render context is probably where the issue is. Yeah, there we go. And bounds, and we also need to use super color. And charm result. Oops. Charm result. And we also need to include, oops, not super, standard format debug to satisfy this. And what's wrong with our color input? Oh, I see what's going on here. It's mad because we don't have STL color. Are we good? No. Source window. It's mad. Okay, also doesn't have color, huh? There we go. Okay. Do a commit, refactor, separate modules. Great. Okay, we want to make the first charm component, whatever. So let's do that after a bite of oatmeal. So we create this and mod stacks, view stacks, vstack. That's how we're gonna do it, I think. Oh, I made the charms folder in the wrong place. That's really stupid. Okay. Oops. Now if I go to source lib, mod, and touch charms, stacks.rs. Let's just do stack. Okay. Okay. Stack.rs. So pub struct v stack. Cool. And this is going to have children, which is going to be a vector of din component. Fantastic. Did I use vecbox somewhere? Because that would be silly. Okay, I didn't. Cool. Cool. So let's look at our example again. So impl vstack function new should just do nothing. Well, it should return a new vstack, but it shouldn't do anything cool yet. So we have children. And we will eventually have a size. So here's what we'll do. So if you pass in a size, it'll be that size. Otherwise, it'll fill to, it'll fit the parent. So if we pass in the size of 400, 300, it's just going to be 400 by 300. If we don't, it's going to fill all 1200 by 600 pixels of the window, which I think is fair. And actually, I'm going to go into layout, and I'm actually, in addition to bounds, I'm going to create pub struct size. And I'm going to derive all this same stuff. And I'm going to do width usize, width pub height usize. And we are going to impl from usize for size. And pub function, pub doesn't need to be pub. Self, and we'll do the classic width height, and we'll go with height. Incredible. I see. It's unsized, so we need. We can either do that, which is another Level of indirection. We do that? No, because it's not really an auto trait. We want a box. We want a box here. Okay. Cool. We might have a background. Okay. So let's make our setter functions. It's gonna have to consume self, which is again really, really annoying. And in fact, that might be an issue in the future. That's really, really annoying. Because I'm thinking, we will deal with that when we get to it. Do not overthink things. Cool. I'm actually gonna do that. Pub function size, itself size impl into size self. Then we're gonna say self.size equals some size, size into self, and background fill background. Slash back. Oh, this isn't even the same thing though. This one's fill. I was trying to like Vim mode there. I don't know. Cool. So we have size and backgrounds. We have our setters. We're good. Add child. Now the fun part. We can implement component. So implement component for vstack function render. Whoa. I don't know why this is red, but I'm actually gonna do that because I feel like it's a bit less annoying. Actually, let's do it like this. That's a little bit cleaner, I think. So then we can actually do that and delete that, and then so here's what we're gonna do. Okay, so our width and height. So our size is going to be self.size as ref unwrap or dot cloned, I think. I might have just lost my language server, so let me restart it. I have this weird bug. Stack.rs. Come on. Cloned? Oh. Unwrap or bounds. Let's also implement from bounds, and we will do bounds with height dot dot, and we can do this. This. Wrap or context dot bounds like here, right? There we go. So there's our size. Okay. Let's get our XY from context. Context.bounds. Import bounds and size like that. Oh, right, dot dot like that. Cool. And are we good here with the moving? Like, is it smart enough to know that we use X and Y in one call and I think so. Okay, so yeah, we can because I think we're moving out of bounds. We're moving bounds here when we use into. So yeah, cool. So context.canvas dot fill rect fill rect oh we don't want to use canvas, we want to use our own. And I broke the server again. I don't, I think it's a Lua bug. Cool. So we want to do context.fillRect. And did it just die again? Whatever. If let some background equals self.background. Because otherwise we don't need to fill in a rectangle here at all. So that's pretty cool. What? What's the issue here? Expected bounds. Here. Is it gonna let me do this? I'm curious. Yeah, oh yeah. I thought this was a trait method, so I got confused for a sec. Here's what we're gonna do. Let bounds equals bounds dot into. Let color equals color dot into. And if we pass in a bounds here, by the way, it'll be a no op here. So this won't have a noticeable impact on performance. Context needs to be mutable, so that's an issue. Oh, I'm sorry. Mute goes here. Like that. Okay. Yeah, and then put child in self.children child.render. And actually, you know what I'm thinking about now is that when when a when ooh, sorry. So when something renders, when it finishes rendering, I think we might want to have it return the size. Because say we have a VStack and we have a bunch of children with different sizes. Like say the height of the first element is 10 and the second one is 30. We'll want to put the second element like 10 below the first element. So we want to increase the y by the amount of height pixels were rendered each time. So we need that information when we render a child. So here's what we're gonna do. We're gonna go into render and we're gonna return let's just return bounds for now, I think. because we'll probably need more information in the future, but I think bounds will be okay for now. Yeah. Oops. Something like that, right? And then we can do child. Okay, so here's what we can do. So we can say let xy we will say let y equals 0, right? Then we'll say I don't think we can pass context in like this. Wait, what? Oh. Right, we have to we so okay, so here's what I'm gonna do. So I need to make a way to change the context, change the bounds of the context, but keep the canvas. So we basically need to clone it. Yeah, we need to clone it. And it's a mutable reference. So how are we gonna do that? We need a way to get the context back after. So do we need to pass the context back to the Caller? I think we do. How long have we been going now? About 2 hours. Okay. We might have to not give ownership of the context. We might have to take a reference to context. And that's a bit annoying. So that works. Okay. Mm, no, this is not good. I don't like this. Okay, we need a way to take this reference out. So okay. Yeah, we need a way. We need a way to return the render context after we're done with it, I think. Which is kind of stupid. Like, it's kind of stupid, but I think that's the way we gotta do it, right? But then, oh, that's so annoying. I think we should split bounds. I think we should split up bounds from the canvas. I think. Yeah, here's what I'm gonna do. I'm gonna make a renderer, and this is gonna be renderer, And this is not going to need that thing anymore. Renderer, which is a stupid name, but there. And then we won't have to pass that back anymore because that's kind of stupid, I think. What is it? Do we need... Okay, so we need a... And this is not going to be like that anymore. It's going to be owned, but then we're going to pass like that. Cool. I think that's much better. Yeah, that is so much better because then we can use R after, right? Yeah, I think so. Okay. Okay, so here's how our context is gonna work. So we're gonna have let ctx equals, and we're gonna clone it each time. Which should just copy it. It should just mem copy it internally because it's just numbers. There's no pointers. Actually, we're just gonna do clone. Really? Oops. Derive clone copy. Right, it should be copyable. Right, and ctx.height, or sorry, .bounds.height is going to be equal to. So I think the maximum. No, components should be able to take up as much height as they want. Okay, yeah, this is fine. Okay. ctx.y or .bounds.y is gonna be is gonna get bounds.y. It's good. So we're gonna increase it each time. And ctx.bounds.height is gonna decrease by bounds. Oh, sorry. This is the height, not y. There we go. So we're gonna say like draw the next component height pixels down, and also we're gonna decrease the amount of height that next component is allowed to take up, which I think makes sense. And then yeah, so we took up that much space. Okay, cool. Is that it? I mean, we don't really have. Okay. Let's try it. I think we'll try it. Oops. And we only have v stack. We decided to do sizes like this, and why is it not? Okay. There we go. Oh, I see. Let mute. And then this is really annoying because we have to say window equals window, right? Oh, okay. Okay, let's try it. Oh, I see. Window.rs. We have to do the whole rendering thing correctly now. like that, right? Oh, sorry, render. Oh, okay, we need, ooh, okay, we need to create the renderer. Um, Here's how we're gonna do it. And in fact, I think we're gonna move the responsibility of yeah, okay, here's what we're gonna do. Okay, we're gonna do render. Oh shit. That's really annoying. No, that's not what we're gonna do. Hmm. Sorry. Component. We might actually want this to be a reference after all. I think. Yeah. Yeah. Okay. Okay. Yeah, that's fine. Canvas. Oops. Canvas. Mute. Render window canvas, right? And then we're gonna create our renderer. Canvas. It's immutable. Do we satisfy the compiler? Probably not. Let's see. It's compiling. So that is not what we want. It's not rendering the vertical stack. So what went wrong here? So our VStack has a size, it has a background, which is red. So ooh. Okay. Let's some background fill. Right. Filling rect. We have this, which is unwrapping, so it should work. Do we need into? It's like, can we convert that? Oh, are we not calling render on the window? That's silly. Okay, wait. App.rs. Oh, we're literally just not calling render on the window. So that's. I'm sorry. Why can't we mute? We're not ref mute. There we go. Okay, let's try it now. Look at that. Look at that. We've got a rectangle. I don't know. Okay, wait. Our homebrew Twitch chat viewer is not working, so we have to fix that in the next stream. But yeah, we have a rectangle. How long have we been going? 2 hours. Not bad, not bad. It's getting very purple in here. 1 second. Let's get some brighter light. There we go. Are we looking a little less blue? Yeah, there we go. That's perfect. Okay. Great. Let's. Ooh, I have an idea. Actually, before we get into that idea, let's check that if we don't give a size to the VStack, that it fills the whole window, because it should. Easy peasy. Yeah, GG Nori. Cool. And if I hit escape, it should close. Yeah, so that's perfect. Okay. Okay, the feature I want to implement now is padding. So what I want to do is I want to put a size on this again. 600 by 400, and child. I want to add a VStack as a child, right? And I want that to fill its parent, and I want the background of that to be green. Okay, and I want to do padding. Then we need a padding struct. So top, left, right, bottom. Actually, what's the order in CSS? CSS padding. It goes top right, bottom left, really? Okay. That's really weird, but that's what we'll do. Sure. And we'll hit it with the same derive macros that we've been using. So we'll impl. First, we're gonna impl usize. For padding. So if you just pass in a single number, we want it to be like uniform padding. Right? So top right. If you pass in 2 usizes, we want it to be I think CSS does vertical padding and then horizontal. Yeah. So vert hors, top is going to be vert, right is going to be hors, vert, and finally impl from usize for padding, and in that case it's going to look like top, right, bottom, left, self, top, right, bottom, left. There we go. Incredible. Okay. Now I'm just gonna do a padding of 8. And no method padding, so let's implement it. And let me actually make this public also. Stack. Cool. And if we do a function padding, view self padding, import into padding, self dot padding equals sum padding dot into self. So padding, padding, oops, padding. There we go. And okay, so here's what we're gonna do. So if let sum padding, oh shit, okay, we actually need to do that after the background fill. So if let sum padding equals self dot padding, we do mute here. No, it would be mute x, mute y. Yeah. Actually, here's what we're gonna do. When we create our context, this is gonna be our context for our children. So I'm actually gonna call this child context, just for clarity. Child context dot bounds dot x plus equals padding dot left. Child context dot bounds dot y plus equals padding dot top. Child context dot bounds dot width is going to be minus equals to padding dot left plus padding dot right. Bounds dot height is going to be top plus bottom. Does this make sense? Because oh, okay, we don't need parens here. Because if we have a component like this outer component here, and we have say like, I don't know, 4px of padding on the left, we want to increase our x, our starting x by 4px. But then also, if we were to draw that same with the same width, it would overflow. So we need to decrease the width by 4px. But then if we also, at the same time, have 4px on the right, we don't actually need to do anything with the starting x, but we do need to take that 4px away from the width as well, so that we have our width is equal to this width minus 8px. And then we do the same thing with height as well. I hope that makes sense. Cool. Is that it? I think so. Let's try it. Attempted to subtract with overflow. So we had an overflow. Okay. Let's get a backtrace. At vstack.render 75 at our height. So, oh. Oh, okay. It's because we didn't use child context here, so that is a problem. Whoa, we forgot to update the width, huh? actually, here's what we're gonna do. No, we're just gonna do it here. There, we forgot to, so we determined the width here based on a calculation, but then we didn't actually put it back into our context. So when we cloned our context, even though we had a fixed width and height, we were just using the width and height of the window that we were originally passed in here. So the solution here was just to set the context of the child context, set the bounds of the child context to the width and height that we calculated here. And there we go. So now we have a yellow window with a red VStack with a child VStack with padding, and we didn't have to like calculate anything ourselves to get the padding. We can increase this to 16 and restart it, and it's got more padding now. And you'll notice the parent component, parent VStack isn't increasing in size or anything, but we could even do unequal padding. So we could do 64 by 16. So we should have 64 pixels on the top and bottom of the VStack and 16 on the left and right. So we fucked up. What did I do wrong? Oh, I see. Yeah. Yeah, I had bottom set to the horizontal padding also, so that was wrong. There we go. Yeah, so we have 64 pixels on the top, 64 pixels on the bottom, 16 on the left, and 16 on the right. So yeah. And in fact, okay. I'm gonna make a commit. Ooh, let's commit some things separately. So let's do let's commit that refactor we did on the renderer. So it would be this one, this one, this one, not this one, not this one, not this one yet. This is gonna be component renderer. Yes, this one. Yes, this one. Yes, this one. Factor. Split render context from renderer to manage to allow. So what are we allowing? So the problem was that if we wanted to change the bounds in the render context before we pass it to a child context, we'd basically have to modify our render context. And sometimes we don't want that. Allow components to pass a different context to their children without mutating their own context. I think that's a fair commit message. And then what do we have after that? VStack. Charms, basic VStack charm. Oh shit, and we have to actually add the charms folder to that. Add create basic vista. Okay. With sizing, padding, and children handling of children, and yeah. Okay. With sizing, padding, and ability to render children. Incredible. Cool. Okay. I'm just trying to think how much longer I want to go with this because I'm kind of getting tired. Like I'm having fun, but like sleepy, and I don't want the stream to just be me like staring at the screen and like typing a couple things and not speaking much. Okay. I want to get to a point where we're just about to implement text, but not quite. So is there anything else that needs to be done before we can start working on text? Because basically the next major things that need to be done are text, rendering text, and event handling. Because we have a store set up, but we don't have an ability to we don't have an ability to modify the store. We don't have an ability to see if we're hovering over something, if we're clicking it. I wonder if I want to try implementing this thing where we can potentially render based on the store. And I think what that's going to require us to do is, I think I'm going to close layout. I think component will have to be generic over store. Because yeah, I think that's going to be the case, because we're probably going to have to pass the store into the render function, huh? Let's try it. Let's see if we can get store into the component as it is now. Cool. And store can be any type, I think. Yeah. And then window is going to be generic over store. But that's going to be a whole big thing because we have to make it phantom data, which is really, really annoying, and I hope that gets fixed soon. And then, oh, actually, no, we don't, because we can do that. Fantastic. Okay. And component store. And render is gonna take a store. Yeah. that's also going to make this happen. Which requires that. There we go. App.add window. So window has an unknown store type, which is kind of annoying. I wanted to just take on the store of app. I feel like the compiler should be inferring that, right? And this is also going to be unit by default. I'm curious why the compiler doesn't know what this type is. But I mean, we could turbo fish it. Oops, let's actually do it like this. I feel like this is a little nicer. Okay, and let's update our stack. So now, kind of annoyingly, our stack is going to be generic over store. And so are the children. This might cause problems later. But let's see. Store. Oops, sorry. Store like that. Impl store component store for vstack store. Store is not going to sound like a word anymore. For fuck's sake. I'm just going to drop the debug requirement on create. I'm just going to break other things, but hey. Yeah, I know. Okay, there we go. Are we compiling? No. Oh, okay. This is an issue because vstack is also debug. I think we might write a custom implementation of debug later, so that we don't have to require a debug impl on store, which isn't really an unfair thing to require on store, but I don't know. I don't want to. Okay, so let's try. Okay. Let me try something. I want a parameter type. So okay, so here's what I want. So I want to be able to do this, right? Store.count or something like that. So I want a parameter of type t, which contains function called resolve, which is going to be a function. We can over type store t. T being derived from store. Okay, great, yeah. Right? And so from t for parameter t, right? And this would be move, I think. Oh, and this has to be generic also. And this also can be any store. Okay, and this should be a. I'm not sure why this closure is not coercing to a function pointer, right? Because it would be like that, right? Coercing to func pointer rust. Right, this should. Let's try like this. Oh, but this can't. Oh, I see. Because this can't capture. Fuck. It can't capture can't capture value even though we're moving value. Okay, how do we do this? We can just say option T, maybe. I think this works better. We can say, oh, you know what? We can make this an enum, actually. And we can say resolve from store, or a thunk. Let's call it a thunk. And in the case that it's a thunk, it'll take a function, and if it's constant, we'll do it like that, and we will do self constant, right? Value, right? Okay, and then if we do an impl parameter, right? Impl t store, right? Parameter of t store, and we do pub function resolve, and this will be a great function. And this will be a self. And ooh, and I think T might have to be clone, which is can we do that? Because we can do match self, right? Ooh, but then we can't. Hmm. Let me try this. Oh no, this can't be done. This is going to have to... I'm gonna make it require that T is clone for now. Okay? Oh, fuck. Fuck. Return fuck of store. Right? Otherwise, if it's constant, is this a keyword? Yeah, it is. Wow. Dot clone. And we're gonna require that T is clone here, I think. For now. For now. Just for now. I promise. Maybe. So otherwise, so can we? I don't know if I can do this because we already have a generic implementation. I don't think I can do store. Oh yeah. I don't think I can do this. Unfortunately. Which like I don't even know what's going on here. Yeah. Oh I can wait. Oh yeah. I think I can do this. Okay. Wait. We're getting somewhere. We're getting somewhere. Okay. Let me try. Option parameter color. And here's what we're gonna do. We're gonna say fill is gonna import into parameter color. I think. And we'll do that, right? And then we'll say self dot back background fill dot resolve store. Ooh. Why is it like that? Oh, because I forgot to do this. I'm an idiot. Okay, wait. Type. Oh yeah. Store. Yeah. Okay, I'm not understanding this. Cannot move. Why can't we move out of it? Can we do that? Yeah. Oh yeah, we can't. Wait, why does this require? Hold on. Why do we require? Do we require mute self for a parameter? Yeah, why do we do that? We don't need that. Yeah, exactly. Okay, I don't know what I was thinking. Yeah, no, don't. Yeah, don't move. Okay. Cool. Now I think if we go back to our basic example, of course it's not working. Okay, type. Why do we need type annotations? I don't understand this. Shit. Okay. This isn't a function pointer somehow. What are we? Why isn't this? Expected one argument found 0. Here's what I'm gonna do just for now. Store.count 0, 0. Oh, I know why it's not happy. It's because we're gonna have to do into here. And store.count 0, 0.into, like that, I think. Yeah, but it's still mad. I don't really know why. Because this is a constant, this is a function. Oh. Let me try, I don't know if I accidentally intoed the wrong, okay, now. I don't understand why this is happening. Equal t. Parameter types, other following types implement trait from t for a function. Why isn't it coercing it into a that BG function? It's that, right? Okay, so BGF as function store color. BGF equals that, right? Okay, it's color. Cannot find color in the scope. You can fix that. Yeah, so... Huh. Do I have to do it explicitly? That's really annoying. That is really, really annoying. And also, let's try to do it so we can still use an into. Let's say... we'll do t, p, p, where t into p, right? What? Input t from t for t. Okay, wait. Oh yeah, now it's mad because fuck. Yeah, okay, here's what I'm gonna do. I'm gonna take this, because I think this is the best way to implement it. Oh, what's wrong? Input t from t for t, t into p. How is this? How is this? What? How so? From parameter. Why is it assuming it's from parameter? Oh, is it because Why would... Implementations from parameter. Wait. You have to be fucking joking. I see what's going on here now. No, I see what's going on because... Wait, no. Oh. Let me try this. Hold on. Right, okay. Yeah, okay. P. This might be T. This might be a T. And to T. And some data P. And unreachable. This is very unfortunate. Let me see if I can do what I think I can do here, because impl T, right? Where T to P, right? I think I can do that. Right. And yeah. And then we resolve impl P. This is really fucking messy. I'm sorry. T. Func store. Oh my god! Stop. Really? Okay, wait. T is clone. P is into T, right? Oh no shit. No, T is into P. So T is clone. Into P plus clone. Right, okay. Now this should work. From T is into P. Right, okay, so trait from T is implemented for into parameter color. Why is it required to trait from P? Color from integer is not satisfied. I don't understand why it's not satisfied. So T can be anything. Oh, that's our problem, is T can be anything here. Oh, this is such a rabbit hole. I'm like bending over backwards to make this API like fucking like we might have to take a step back. Ooh. So we can't have P. It's gotta be it's gotta be like this, and it's gotta be like this. Oops, it's gotta be like this. And oops, and I want to keep this as t. I don't really want this to be like that. And we're gonna have our issues. Okay, wait, so t, oh yeah, t, like that. Okay, so again, let me figure out what this is saying. So this is saying that impl t from t. So where are we saying that you can implement? So we're saying that if t implements into p, let me pull up the Photoshop. So, oops. So we're saying here, oh my gosh, wait. So we're saying that if t implements, if t can become a p, we're saying that t can become a parameter p. And the issue is that if t can become a parameter p, wait, t into p, then parameter p, impl t from t for t. What if we just create our own into parameter trait? Right? Or like whatever, like, yeah, right? And then we import, yeah, we import all this shit, right? But it becomes into parameter of type p for t. Okay, why is this? Import right store parameter, right? And this just becomes parameter const, right? Self.into, right? Yeah. Yeah. Okay. Right, and then I assume we could do the same thing, right? Like it could be like impl e store, right? Into parameter e store for fn store to. We could even do like like this could even be like something else, right? Where t into p, right? We could do that, right? No, we can't. Type 4a. 4a is not, does not implement into though. Into parameter. Oh wait. Thunk into parameter, right? Can we do that? No, because the no, we can't do that. No, 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 no. Okay, 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 okay. I let's just say pub function dynamic fn parameter function function parameter function thunk f parameter self t store where f pub function f sorry f t self p function store t is into p what t p, right? Yeah. Oh no. Oh shit. No, no, no. Wait. Oh. Oh. Oopsie. Self t. Oh, it's just self. Duh. Import. Right. Is there a trait for things that can be coerced? Because now this is an issue. FN. Oh, can this be? Okay, wait. Okay, wait. There. Parameter store is never used. Dog, really? Really? Like, I don't want to add this, but I have to, right? In order, unless I want to use a phantom data, which I really... Oh no. Oh wait. Oh my gosh. Good lord. Okay, wait. Right? And this would be let's make this a struct again. I'm sorry. This is taking way too long. And right? And then oh god. Okay, wait. Self no parameter thunk self 32. Right? No. Yeah? Yeah. Phantom data. Oh yeah. Okay, now this has to be. Oh shit. Oh, for fuck's sake. Okay, wait. Okay, wait. Oh no, this can't even be. Wait. Oh, okay. Wait. Self.into. Oh my god, I'm losing my brain. I'm losing my brain cells. I should not have done this. P store F. Wait, so what are we doing here? So we have a thunk, right? And that should resolve to a T, right? So we can. I'm just gonna get rid of all of this right now. I'm sorry. We need to actually type erase this. That's the issue. We need a box of din store to type T, right? That's our issue, and we need to import T store parameter of a T store, right? And so we need to do constant from constant, right? And that would be constant import into T, right? And so then we can do let val equals, or let constant equals constant dot into, and then we can return a self with the thunk equal to box new of underscore to constant, right? Right. We just need to do this. Right, there we go. And then from thunk would be thunk import enough store to O, right? And O is gonna be into T. And what we're gonna do there is we're gonna say self thunk box box new store, and we're going to say thunk store dot into. And what's the issue here? This does not have a return type again. So that works. And let's do closure. And let's do enable e-store e-store from T for parameter. Is this going to be the one that gives us a circular thing again? I think so. Yeah, okay, so we need pub trait into parameter. Into parameter store. Function into parameter pt store into parameter value p, where p into t will give you oh sorry, t, where t is into p. P is our parameter. Kind of a confusing signature. Parameter p store, right? And yeah. Uh, right. Right? And can we just do a default impl? Wait. Oh shit, no, we want to do like that. The impl. And actually, this is just going to be a t to store. Oh no. It's going to be any. Yeah. Oh, okay. I see what's going on. PT store. Uh, PT store for t where t to be parameter. What the fuck? Wait. Function parameter. Parameter from constant to. Oh my god. Okay. So yeah. So what's gonna happen here? Unfortunately, parameter closure is gonna have to look like this, I think. I'm a little bit confused why nothing's happening with the like. There's no errors. Yeah, because the errors are all here. So instead of into this, it's gonna be. Oh shit! Wait. Okay. Wait. I think I did it wrong again. Oh. Wait. Hold on. Hold on. Right. Oops. Yeah. That's right. That's right. That's much better. Okay. So this would be here. This would be. I'm so sorry for the like, um, mental block. Store. Roll that into parameter. Right. Ooh, there we go. Okay. And oh, we need to add back a resolve method. I'm sorry. Component. I'm just gonna call this constant also, I think. And create function equal to t, right? And we're gonna call. Okay, wait. This is gonna take in itself plus store, right? What do we call it? What? Oh, okay. Huh? Wait. Oh, we need to do this. Oh no. Uh, why does thunk have to be borrowed for static? Like, okay, that's fine, I guess. Oh, T. We need to own this. Oh, why won't this live long enough? This is static. Into. And T is static. So where T is static, right? Is that the issue? We're moving it. I don't. We captured it. Okay, but we said move. Wait, so what? Dog, like, wait, why would T is static? We're moving it. Why are we moving it? Yeah, this can have it too. Oh my god, okay, wait. Yeah, what? Okay, wait. Huh. Oh. Okay. Why is it only implemented FN once? Because this, because it returns a. Oh, that's so annoying. Yeah, that's really, really annoying. Oh my god, yeah, okay, wait, when P is clone, right? Thunk store, thunk, okay, of course thunk doesn't live long enough. Ew. Move, right? We can move it. Okay, there we go, there we go. Sorry, that was a borrow checker moment, for sure. I'm glad we didn't have to use phantom data though. Cool. So where are we? It compiles. It compiles. It does not compile. Oh my god, what? Color from. No, but we changed this API, right? So. Closure returns from parameter. I'm very confused why this requires that. Because it's input into parameter, right? Parameter. Oh, does parameter not implement into parameter? Oh, for fuck's sake. Really? Bruh, okay, wait. Oh my god. Okay, wait. is into P. But there would never be a case where that could be possible. Okay, right. Right. So, oh, that's really awful. That's really awful. Here's what we might do. We might say use parameter constant. Can I do that? I can't load the methods like that. Okay, okay, yeah. That's really fucking annoying. Okay, here's what I'm gonna do. I'm gonna scrap into parameter for now. I'm gonna make stack take just a parameter. Parameter color store. And we're just gonna do it like that, right? And here's what we're gonna do. So okay, into this is gonna be parameter constant. And I shouldn't need an into here. Yeah. But we're missing that, and now it's probably gonna cause problems. What? Oh, what? I don't. What? I'm pretty certain. Oh, it has to be UA. I'm sorry. Ugh. Actually, this is not necessary here. This is just me being stupid. As UA. And these work? Oh, because this isn't. These aren't parameters yet. Okay. Okay. Let's make this Let's ruin our API. It was so nice, and now it's gonna be fucking awful, but yeah, we'll deal with it. Padding, option padding, size, option parameter size. Oh, and we're gonna have to even do children as a some sort of parameter. I don't know. Yep. Okay. Unwrap or unwrap. Oh God. And then. Jesus fucking Christ. Okay. Wait. Duck. Oh, and it's not even in that. It's map. I think. So that's cool. Okay. Oh God. Okay. Wait. Padding equals padding dot resolve store, and I would also really like to make some way to resolve all this ref, right? Ref. Yep, and so now these don't work anymore, which is really, really, really sad, but we can do parameter constant. So maybe the way to do this is just to make a function called constant or like cons or something that just returns a parameter, but I really don't like this. It's really sad, but you know, it is what it is. But now our thing has a parameter. Now our VStack has a parameter. I'm losing my mind. I'm literally losing my mind. So I'm curious if... Oh, we don't have a way to change the store yet, so... I don't know, but we can set store equal to 255. And so what did we do? So the background is now going to be 255 red, right? So then we can do 127, and it should just be like a darker shade of red, I think. Yeah, so there you go. So it responds to the store. And so in theory, every time this re-renders, it's grabbing from the store. Which, is that causing this performance issue? I'm curious. Let's run it as release. Oops. Oops. Okay. Yeah, I don't know what's causing that lag spike, but we'll investigate. I'm sure that accessing the store and doing all this shit all the time is really taxing. But yeah, let's add dot and let's do parameter, implement component, implement parameter type for deriving parameter values from the store dynamically. Oh, we can't push yet because I haven't made the repo yet, but I'm gonna make the repo. In fact, I'm gonna do that right now, and that's gonna be our closing thing. Cool, so this is called Charm UI, right? Yeah, Charm UI. And let's add the little like sparkles, or are there like charms or like necklace? Puzzle. Yeah, that's kind of cute. Okay. Immediate mode GUI library, GUI library with a friendly API. I think that's nice. And we'll add all this stuff. Cool. And git remote add origin this, git Git. Actually, let's add a README. Let's do. I'm gonna copy this actually. GUI. And Farm is a lightweight immediate mode GUI. Oh, work in progress. Lightweight immediate mode GUI framework. It currently only supports DL2, but graphics layer is abstracted, so more backends will be available shortly. With a friendly API designed to be familiar. I hate how line breaks work sometimes. Farm currently only supports more. Okay, so that will be available. An example. Rust. Cool. Let's clean this up a little bit. There we go. Yeah. Very cool. Is there anything else I need to add? I don't think so. Cool. Cool. Nice. And let's give it a license. MIT license sounds good. Submit, commit, license, create, license. Okay. I think that's enough for today. It's been how long now? 3 hours and 30 minutes. So that'll take ages to render the VOD. So I think that's definitely good enough. Links will be down below. You're welcome to clone this repo, try it, make a pull request, whatever. And yeah, so in the next stream might or might not be working on this project, but if it is, we will be working on buttons. So that will include rendering text first, handling events, and probably some more like refining this parameter system because it kind of sucks still. Yeah, cool. That was a fun stream. I feel like it was pretty productive. So yeah, I hope you have a great day. Thanks for watching. Yeah, tune into more streams. I don't have a schedule yet, but you know, yeah, take care. All right, thanks for watching. Bye-bye.